All right, chemists, let's hop to it. Double replacement reaction time. Solutions of aluminum iodide and mercury chloride. So, this is a good one because you have to write out this formula, which is a throwback to what we've been doing. So, aluminum iodide. Aluminum is a metal with a +3 charge. Iodine is a nonmetal with a -1 charge. Mercury is telling me has this +2 charge. Mercury 2 means it's mercury +2. Chlorine, it's a halogen with a -1 charge. So when I pair these two up in solution, I need 3 iodines to balance out with this aluminum. Therefore, I get Ali3 in the aqueous state. When I pair up these two, I need 2 chlorines with -1s to balance out with this mercury. Therefore, HgCl2. 2 chlorines to balance out the +2 to mercury. This is aqueous. These will react to form. Now, what's going to happen here is the positives are going to swap partners. So aluminum is going to come and bind with the chlorine. So I have to look at their charges again. Aluminum is a +3. Chlorine's a -1. So when it comes in and bumps out the mercury, I'm going to have aluminum chloride, but that -1 charge on the chlorine, I need 3 of them to balance out the +3. I don't know the state of matter yet. I'm not going to worry about it. So now, let's look at the next one. The mercury is now going to bind with the iodide. Mercury is coming in with a +2. Iodine's -1, so I need 2 of those iodines to balance out the mercury. So, if I want to write that out, HgI2. Try to clear out that G. Alright, so I have this written out, which is great, but I need states of matter. States of matter, you refer back to your solubility table. Look at your anion. Here it's chlorine. Right? If you find chlorine on your solubility table and you follow it over to the cation section, you'll find that with aluminum, it is soluble, which means it's going to stay in an aqueous state. Alright? Now, when we look at the mercury iodide, if you look at iodine as your anion, and you follow it over and you look at mercury, you'll see that these two together are insoluble. So what does that mean for us? It means it's our precipitate. It's the solid that falls out of solution. So I give that an S. This is great. This is looking wonderful, but I haven't balanced yet. We have to balance. Okay? So let's do that. So, 1 aluminum here, 1 aluminum here. I'm happy. 3 iodines, 2 iodines. Yuck. Closest common multiple is a 6. Therefore, I would need a 2 here to raise this iodine to a 6. And I would need a 3 here to raise this iodine to a 6. Okay, so what does that do? Well, it gives me 2 aluminums on this side now. So I'm going to have to bump up my aluminum here. Alright, well, what does that do? It gives me 6 chlorine. So what I got to do? Got to bump up these chlorine. I'm going to put a 3 right there. And now when I look at this, 2 aluminums, 2 aluminums. 6 iodine, 6 iodine. 3 mercuries, 3 mercuries. 6 chlorine, 6 chlorine. I am happy. This is balanced. I know what my solid is. I'm good. Now, if I wanted the ionic equation, I would have to write everything in its ion form except the solid. If you want to write the net ionic, all you got to do is take a look at your solid and what formed it. So there was our solid. What formed it? Well, the mercury and the iodine. So if I wanted to write that out as my net ionic, I'm not doing the straight ionic. I'm just going to the net ionic. I would say, well, I had a total of 6 iodine here. So this was 6 iodines with a -1 charge that were in the aqueous state that combined with 3 mercury with a +2 charge in the aqueous state. They reacted to form 3 formula units of mercury iodide in the solid state. There's your complete double replacement reaction along with your net ionic equation. Okay, enjoy. Study up.